Hello all, in today's lecture we'll be studying about logic gates. What do you mean by logic gates? Logic gate, it is nothing but a digital circuit that is mainly used to take multiple inputs and give you an output to perform a particular logic function. This is the base for any digital circuit that you want to design. In case if you want to design any digital circuit, the base for designing that circuit is this logic gate. This has got two inputs or three inputs depending on the gate that you'll be choosing, and you'll be taking an output from it. Fine. Let's see what are the different types of gates. We'll also see what are their functions as well. Fine. There are different types of logic gates like OR gate, AND gate, NOT gate, NOR gate, NAND gate, XOR gate, and XNOR gate. We'll be studying about all the gates in detail along with their truth table and where they will be using it. Clear? Now let's start with OR gate. How do you represent an OR gate? It is like this. When you give A and B as the input, your output will be a sum of both the inputs. Fine. OR gate meaning it is going to sum up whatever inputs that you are giving. It will sum up both the inputs and then it will give you an output. Clear? How do you draw the truth table for this? A and B are my inputs and Y is going to be my output. If two inputs are there, how many combinations is possible? 4 combinations that you very well know. How to find out the number of combination? It is 2 power n concept. If we have 2 inputs, it is 2 power 2, which is equal to 4 combinations. And what are the combinations? It is 0, 0, 0, 1, 1, 0 and 1, 1. Right? Now, give all the combinations here. Fine. What do you mean by combinations? Either you can give a 0 here and a 0 here. For the first case I am taking. When you are giving 0 and 0, your output will be 0 plus 0, your output will be 0. Clear? So I will be having my output as 0. If it is 0 and 1, if I am going to give my B input, against B I have given 1. So if I am going to give my B input as 1, then my output will be 0 plus 1. 0 plus 1, it is 1. Understood? So my output will be 1. Let's take the third case. When my input to A is 1 and input to B is 0. 1 and 0. I am giving an input to A as 1, input to B as 0. What will be my output? It is 1 plus 0, which is 1. So I will be getting an output 1. Clear? When I am giving 1 to A and 1 input to B, what does it mean? Output will be 1. What do you mean by 1 and zeros? 1 meaning your signal will be like this, right? 0 meaning it is the low signal and 1 meaning it is high, that is 5 volt, plus 5 volt. Whenever there is plus 5 volt, it means that you're going to turn on or you're going to give power to that particular input. Whatever you give 0, meaning you're not going to give power to that 5 volt. It is something like a switch. You turn off the switch and then you turn on. Whenever you turn on, it turns 1. You are giving an 1 input. Whenever you are turning it off, you are giving a 0 input. Clear? Fine. In a similar way, for AND gate, how do you represent an AND gate? AND gate, it is not. You will be representing it like this. When you are giving A, B as your input, I am writing AND gate here. A and B are my input and my output will be A dot B. That is, AND gate will do a product of your input. Whatever input you are giving, it is going to do a product of both your inputs and then it will give you my output. Is that clear? Now, how will you write the truth table for this? 2 inputs are there, so I'll be having 4 combinations. So what are the combinations? You very well know. It is 0, 0, 0, 1, 1, 0 and 1, 1. What is Y? Y is nothing but the product of my inputs. Clear? 0, 0. When I give 0 and 0, what is my output? Y is 0 dot 0. My output is 0. Clear? When I give 0 and 1, when I am giving A 0, B as 1. What will be my output? It is 0 dot 1. I am doing a product. So 0 and 1, when I do a product, my output will be 0. Clear? For the third case, when I am going to give the input to A as 1 and input to B as 0. In this case, Y will be 1 dot 0. 1 dot 0 meaning I am going to product 1 with 0. 1 into 0 is 0. 1 and 1. When I am going to give B input as 1, my output will be 1 into 1, it is 1. So my output will be 1. Is that clear how to write the truth table? Fine. Now let's go to NOT gate. How do you represent a NOT gate? NOT gate is something like this. When you give an A input, your output will be A bar. NOT is also called as an inverter. What do you mean by that? Whatever input you're giving, the NOT gate will do a complement of it. If you give 1, your output will be 0. If you give 0, your output is going to be 1. It will just invert it. It will just complement it. Fine, that is called a NOT gate. How can you write the truth table for this? You have only one input. Other gates, if you see, there are 2 inputs, or there can be 3 input also, depending on the application. You have 3 input NAND gate, 3 input OR gate as well. But for here, we are taking only 2 input for better understanding. Whereas in NOT gate, you can give only 1 input. You cannot give 2 input here. Only NOT gate has got only 1 input. All the remaining gates can have 2 input or 3 input, depending on the application. But to NOT gate, there is only 1 input that you can give at a time. Clear? Now, how A bar. Fine. If I'm going to give 0 as an input, my output will be 1. If I'm going to give 1 as my input, my output will be 0. Meaning the output is going to become a toggle. Whatever input you give, the output will be a toggle of it. Toggle meaning it is just the opposite of it. If I'm giving 0, my output will be 1. And if I'm going to give 1, my output will become 0. Clear? This is called NOT gate. I hope you're clear with this now. Now, we are done with AND gate, OR gate and NOT gate. Now let's see NAND gate and NOT gate. Fine. What do you mean by NOR gate? NOR gate meaning it is OR plus NOT. What does it mean? You're going to complement your OR gate. N meaning NOT. Fine. This OR gate you're going to complement with the NOT gate. So how you will represent it? It is like this. First you will be drawing an OR gate, same OR gate, and then you have to put a NOT. How do you represent a NOT? NOT is with a bubble. Always represent NOT gate with a bubble. So this will be my output. Fine. And what is the equation for this? It is A plus B. You very well know OR gate is nothing but summing gate. So A plus B is OR gate, and since you have put a bubble, you have to put a bar. Understood? This is called NOR gate. Is this clear? How will you write the truth table for this? Here again we have only 2 inputs, A and B, so my combinations will be only 4, 0, 0, 0, 1, 1, 0 and 1, 1. Fine. A and B I'm going to add, and whatever output I'm going to get, that I'm going to complement. By adding, if I'm getting 0, my output will become 1 because I put a bar. Bar meaning it is complementing. Bar meaning it is complementing. Clear? In the NOT gate, how did you represent the output? With a bar. Wherever you see bubble, it means you have to put a bar. Bar meaning you're going to complement whatever output you're getting. Clear? Now, A and B. What is the output of it? It is A plus B. A plus B is, you can write it separately like this also. This is OR gate. And for NOR, it is A plus B the whole bar. Correct? So how can you represent A plus B? It is 0 plus 0, it is 0. But complementing 0 is 1. Understood? So A plus B is 0. Ideally it is 0 for OR gate. But in NOT gate you will be complementing it by 1. Whatever output you are getting with addition, you are going to complement that output. Clear? Now take for the second case, it is 0 plus 1. It is 1 actually, but in NOR gate we have to complement it. The complement of 1 is 0. You just have to toggle it. If it is 1, you have to change it to 0. If it is 0, you have to change it to 1. Now, check for this. 1 plus 0, it is 1. But you have to toggle it. So, on toggling, you will be getting an output 0. 1 plus 1, you very well know it is 1. But on toggling it, it will be getting a 0. Understood? How to write? When you check on the NOR gate truth table and the OR gate truth table, it will be just the complement of this. Wherever you have 1, 0, you will be representing that with 1. Wherever you have 1, you will be representing that with 0. It is just the complement. That is why I wrote like OR gate plus NOR gate. Whatever OR gate logic is the same, but whatever output you are getting on the OR gate, you have to complement it. That is NOR gate. Clear? Now, shall I erase this? Okay, if you want, you can copy it. NAND gate. How do you represent a NAND gate? In a similar way. NAND meaning it is AND plus NOT gate. What does it mean? Whatever output you have in the NAND gate, you have to complement that to get your NAND gate. Clear? Now, how do you represent that? You'll draw AND gate first, and then for the NOT, you'll be representing that with a bubble. Now, A and B. For AND gate, what is the output? It is A dot B. But since we have a bubble here, we have to put a bar. Understood? Now, give me the truth table for this. You have two inputs. So, how many combination? You'll get 4 combination. Right? Now, give me the output of y. Y is what? A dot B. Whatever output you are getting for A dot B, that output you have to complement. For the first case, y equal to A dot B. This is AND gate. But for NAND gate, it is A dot B, the whole bar. Fine? A dot B product is what? 0 dot 0, it is 0. But since I have to complement in the NAND gate, my output will become 1. The complement of 0 is 1. Understood? For the second case, 0 dot 1. 0 dot 1. 0 dot 1 meaning you are going to do the product term. So 0 into 1, it is 0. But you are going to complement this. So my output will become 1. Clear? 1 into 0 is 0. You have to complement that output. So 1 into 0 is 0. Complement of 0 is 1. 1 into 1 is 1. You have to complement the output. So 1 into 1 is 1. Complement of 1 is 0. Clear? Here again, when you check whatever output you have got for the AND gate, NAND gate is the exact opposite of it. Here, when you check on the output, it is 0, 0, 1. Wherever you have zeros, you have got 1 here. Wherever you have got 1, you have got 0 here. NAND gate is just the opposite of AND gate. Clear? Okay. I hope you're clear with how to draw an OR gate, AND gate, NOT gate, NOR gate and NAND gate. I hope you're clear with this. Now let's see XOR gate and XNOR gate. XOR gate. XOR gate you will be representing like this. A, B and Y. Fine. And what is the expression for Y? It is A, B bar plus A bar B. This can also be represented as A plus and then a circle and then B. Clear? This is another notation for representing XOR gate. Now, how to draw the truth table for this? Now, A and B are the two inputs. So, how many combinations we can get? We'll be getting 4 combinations. 0, 0, 0, 1, 1, 0 and 1, 1. Right? Now, why did I write A bar, B bar, A, B bar and A bar, B? That is just for simplifying. Since we have got A bar here, B bar here, I'm just representing them separately so that it will be easy for you to understand better. Once you are clear with understanding, directly for the truth table, you can mention like this. A, B and Y. Since it is a first class, I'm just elaborating it so that it will be easy for you to understand how to write like this. Clear? Now, A, B, it is there. These are the inputs that we very well know. Since we have A bar, B bar there, here in the equation, I've written A bar separately and B bar separately. And then this product term I've taken it here, this product term I've taken it here. Fine. Now, what is A bar? A bar, I told you, whatever is there in A. If you have a bar, meaning that particular variable, that value for that particular variable will get complemented. If it is 0, it will get complemented to 1. If it is 1, it will get complemented to 0. So, for A bar, what are the variables for A? What are the values that we have for the variable A? We have 0, 0, 1, 1, right? So, for A bar, for the first term, 0 will get complemented to 1. And for the second term here, it is 0, so it will become 1. Here, so it will become 0. Here it is 1. Here it will become 0. If you have 1 for bar, it will get complemented. Here, if it is 0, it will get changed to 1. If it is 0, it will get changed to 1. If it is 1, it will get changed to 0. Why? Because you have a bar here. Clear? A is your actual variable. So these are my actual variables. For a complement, A bar meaning you're complementing it. Clear? Complementing means whatever values you have here, it will get complemented. If you have 0, it will just change to 1. If you have 1, it will get changed to 0. Clear? Now, let's try for B bar. We have the values for B here. Fine. You have to find out and tell me what is the value of B bar. If I have 0 here, what will be the value for B bar? It will be 1. If I have 1 here, what will be the value for B bar? It is 0. For 0, it will be 1. For 1, it will be 0. Just the opposite of it. Clear? Now, A, B bar. I have A here and then B bar here. These two, I have to do a product term. I am going to consider only these two boxes. Clear? Forget about what is here and then do a product of these two. A 0 into 1 is anything multiplied by 0 is 0. So 0 into 1 is 0. 0 into 0 is 0. 1 into 1. 1 into 1 is, it is 1. 1 into 0 is 0. Understood? Clear how to fill this table? Now come to A bar B. A bar B is, A bar is here, B is here. So forget about these two and then consider only these two boxes. Here, 0 into 1 is 0. 1 into 1 is 1. 0 into 0 is 0. 1 into 0 is 0. Clear? Now, what is Y? Y is A B bar plus A bar B. We have A bar B here. A B bar is here, A bar B is here. Right? These two terms we have to do a sum. We have to add these two terms. Forget about whatever you have here. Concentrate only on these two terms. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. 0 plus 0 is 0. Clear? So my final truth table will be, for an XOR gate, it will be like this. What are the values? 0, 1, 1, 0. 0, 1, 1, 0. Understood how to write the truth table for an XOR gate? And is clear? Now let's solve for XNOR gate. We are done with XOR gate also. Now let's see how to do it for XNOR. XNOR again, when you have an N, it means you're going to do a NOT of it. X और के बीच में N है. So it is something like you take an XOR and do a NOT of it. Clear? You're going to complement the values of an XOR. How do you represent? You'll be representing it like this. It's not as there, I'll put a bubble. A, B and Y. Clear? This can also be represented as like this. And the equation for this is AB plus A bar B bar. Is it clear? Now, how to write the truth table? Two inputs are there. So what are the combinations? 0, 0, 0, 1, 1, 0 and 1, 1. Fine. Now what are the terms we have? A bar, B bar, AB, AB bar, A bar, B bar. And then we have Y. Clear? In a similar way. Can you give me the values for A bar? A bar is what? Whatever values you have for A, it is a complement of it. If we have 0 here, for A, here in A bar it will be 1. For 0, it will be 1. For 1, it will be 0. For 1, it will be 0. Right? Now, for B bar, here it is 0. So B bar will become 1. Here it is 1. So B bar will become 0. Here it is 0. So B bar will be 1. Here again it is 1. So B bar will be 0. Clear? A, B. We have A here, B here. So product of these two. Forget about this. Consider only these two columns. 0 into 0 is 0. 0 into 1 is 0. 1 into 0 is 0. 1 into 1 is 1. Clear? Now, A bar, B bar. A bar, B bar. Do the product of this. 1 into 1 is 1. 1 into 0, 0. 0 into 1, 0. 0 into 0, it is 0. Clear? Now, what is Y? Y is nothing but AB plus A bar, B bar. Clear? Now, what have I done here? A, B we have, A bar, B bar we have. You have to do a sum of both the terms. Now, give me the sum. 0 plus 1 is 1. 0 plus 0, it is 0. 0 plus 0, it is 0. 1 plus 0, it is 1. Understood? This is how you'll be writing the truth table for XNOR. In a simplified version, you can mention it like this. A, B, Y. So if you have the combinations like this 0, 0, 0, 1, 1, 0, 1, 1, your output will be 1, 0, 0, 1. When you check for XOR and XNOR, you can find out, check only the values for Y here. Wherever you have 0, it is 1. Just the complement of it. If you have 1s here, here it is 0. If you have 0 here, it is 1. Clear? XNOR plus NOT. What does it mean? Whatever values you have got for XOR, the complement of it, you take it and you will get XNOR gate. Is that clear? Where do you apply this XNOR gate? We have home security system nowadays in all the houses, right? Maximum of the houses has got home security system. What do you have in that? You have a small digital circuit. Inside that circuit, they'll be mostly using XNOR gate. Say for example, like A and B are the two users. Let A be the owner of the house and B be a member of the house. Both will be sharing the same password for entering inside the home. You'll be mentioning a password before entering inside the home. That is a home security system, right? Now, if the owner and the member of the house, B can be either member or it can be outside person also. Let's consider B to be a member of the house right now. So what, I am the owner and you are the member of the house. So if I am going to type some password and I'm going to lock my house. So in case in my absence, if you want to come and open the door, so you will also be having the password, same password, since you are a member. So I have trust on you, so I'll be sharing my password with you. Now we both will be having the same password, right? So when we are having the same password, that is like 0 and 0, 1 and 1. Both are having the same password. Fine. In that case, the door will open. Say for example, there is some intruder. Let that intruder be B. A is the homeowner, I'm the owner, and B is some intruder. Fine. Intruder doesn't know my password. I don't share my password with any intruders. And if they're trying to peep in inside your house, what do? They try to give some password to open inside the house. But that password is not going to match. My password is this, but the intruder's password is this. Both the numbers are not matching. I have given 0, he has given 1 because he doesn't know what my password is. Right? If both the numbers are different, then the door will not open. That is 0. Only when both the numbers are matching, either 0, 0 or 1, 1. Meaning, when my password and the other person, whoever is trying to step in, his password or her password, if both the password match, only then the door will open. If both the passwords are different, here it is 0, here it is 1, or here it is 1 and here it is 0. When you have different input combinations, the door will not open. Only if you have the same kind of input combinations, the door will open. If you have different combinations, the door will not open. This is one example for you for the XNOR gate. In a similar way, we will be studying about in detail about all the gates in our coming lectures, and we'll be solving few problems based on the logic gates as well, so that you'll get a clear and a better understanding of how these gates are implemented in real-time applications. Clear? To sum up, today we studied what a logic gate is, where we are using the logic gates, what are the different types of logic gates, OR gate, AND gate, NOT gate, the truth table for all the gates, and the applications also. I hope you're clear with this topic. If you find my lectures useful and informative, please do like, share and subscribe to my channel. Thank you.